Hello everyone, and thank you for joining us for this joint webinar by WiseFood and DietWise project on the responsible use of AI-powered digital tools to help turn users into informed, empowered citizens, while also promoting more sustainable and environmentally friendly food choices that can help reduce food waste. I'm Sandra Kolaric, Communication Manager at FoodScholar Hub, and I will be moderating today's session. We can move to the agenda now. I will share screen to show you the agenda. Everyone should see it now. We will start with a presentation about WiseFood project and DietWise project from both coordinators. First, it will Dimitris Skoutas from Athena Research Center will present WiseFood project. Then Siegfried Dewitte from KU Leuven will make an introduction to the DietWise projects. Then we'll explore WiseFood applications. First, Vasiliki Pitsilou from Athena Research Center will showcase FoodScholar, followed by Elizaveta Kuzmenko from Université Libre de Bruxelles, who will present FoodChat. Next, we'll turn to DietWise project, focusing on smart ICT tools for dietary advice. Nikos Paraskevopoulos and Nathalie Kusta from Institute of Communication and Computer System of the National Technical University of Athens will present DietWise project and development of these tools. After that, at the end, we will have Q&A session. During the webinar, you can type in the chat questions that you have, and then we will at the end also go through those questions. To start, we are pleased to hear from Dimitris Skoutas, who will walk us through WiseFood project.
Thank you very much, Sandra. Just give me a second to share the presentation. I believe you can see the presentation now in full screen mode.
Yes.
So I would like to thank, first of all, very much everyone for joining this webinar, for your interest, both in the WiseFood project and in the DietWise projects. My name is Dimitris Skoutas. I'm a researcher at Athena Research Center in Athens, Greece, and I'm the coordinator of the WiseFood project. And we will start with a brief presentation that introduces the project, provides an overview so that you become familiar about what we are doing in this project. And Lisa about the specific tools we are developing in this project. So WiseFood is about leveraging data and AI to empower citizens to make healthier and more sustainable food choices. It is a NEO-funded project, specifically an innovation action. It started in January 2025, and the total duration is 36 months. So essentially, currently, we are almost completing the first half of the project. We have started developing the applications. We have running prototypes. We have been conducting co-design through living lab activities. And soon we will enter the second phase of the project where we further develop the applications and also have evaluations through the living labs with real users. You can find here the links to the website of the project where more information can be found. Also a link to an online demo. Of course, keep in mind that this is a working prototype that is actively under development, and a link to our GitHub repository where the code is made open source and can be used from anyone interested to further develop and build upon these applications. A few words about the consortium. I will not go through each individual partner, but just to be aware about who we are. We have a set of partners that focus primarily on developing the digital applications that we will discuss later on. Another set of partners dedicated to establishing and running living lab activities for co-designing and evaluation of the applications, and of course, also partners that focus more on ensuring that the project achieves the impact and the results are exploited and become sustainable later on. In terms of motivation, I think it is easy to motivate this topic. Healthy diets is something that directly links to our health. A large number of deaths in EU and worldwide can be attributed to unhealthy dietary choices. There are important and crucial problems with people being overweight or malnourished. And on top of that, also, there is another important issue related to food waste, which has negative effects both to the economy and the environment. So a natural question is whether and how we can leverage AI, and specifically generative AI, which we see that is transforming several sectors, and we're living in the generative AI era at the moment, to also achieve benefits and make improvements in our dietary decisions and our food choices. So the vision is to promote healthier dietary habits, to foster a culture of well-informed and eco-conscious citizens. And particularly, we are targeting two main goals. On the one hand, our goal is to remove knowledge barriers, because in order to foster behavioral changes and make people adopt healthier diets and more sustainable diets, first of all, they need to be knowledgeable. So food literacy is one important issue. And then the second goal is to remove action barriers, because often we might be aware about which choices are better, but still we may not act towards this direction for different reasons. So we want to bridge the gaps from dietary guidelines to actual meal planning, reduce the effort and the time and the energy that people need to spend to make such decisions and make this effortless for the users. In order to achieve this, our aim is to build an AI-driven copilot that helps people by providing personalized and up-to-date information and reliable recommendations for recipes and meal plans. Here you can see an overview of the concept of the project. Our approach is data-driven, so on the left side, as a basis, you can see types of data sources that we use, and the important thing here is to base everything on reliable and trustworthy sources like scientific articles and national dietary guides. Then in the center, we have the digital applications that we are developing. Three applications: FoodScholar, Recipe Wrangler, and FoodChat, as we will see later also in other presentations. And again, important here is that this follows an agile approach, and we have living labs where we engage stakeholders and real users, both to co-design and to evaluate the applications. On the right, we can see the different target groups. I would say that primarily we're targeting citizens and specifically households and also dietitians, so both the average user and professional users. And these users can benefit from personalized and reliable information and recommendations. But also, we expect that other types of users, like policymakers and food suppliers and producers, can benefit by gaining insights from the needs and the trends of the citizens, or promoting seasonal and locally sourced foods and ingredients, as well as researchers in the area of food computing, because the tools that we're building are open source and can be further extended and adapted in the future. As I mentioned, we have living labs. I will not go into details because the focus of the webinar is more on the digital applications. But just to mention briefly, we have the three living labs in Ireland, Hungary, and Slovenia for co-designing and evaluating the tools. And the aim is to cover different characteristics in terms of socioeconomic background, traditions, preferences, regional information, and so on. A few words about the digital applications. The first one is FoodScholar, one of the two that will be presented in this webinar. The main goal of FoodScholar is to extract information from reliable sources and make it easily available to users, both through summarization and generation of tips, and also question answering. So essentially, from a technical point of view, this is a RAG system that retrieves information from selected data sources and summarizes it or answers questions. Then we have Recipe Wrangler, an application that, as the name suggests, deals with recipes. It allows users to search for recipes according to various criteria, to create recipe profiles automatically by analyzing the ingredients and calculating different types of scores, and also beyond profiling to adapt the recipes based on certain criteria, for example, to increase the nutritional score or the sustainability score, or to reduce the time and the effort or the cost required while still maintaining high quality recipes. And the third application, which will also be presented today, is FoodChat. This is a conversational recommender system. The main goal is to make it easy for users to generate meal plans, both daily and weekly meal plans. And the main challenge is to ensure that these plans are aligned both with user preferences, so that these recommendations are attractive and actionable, but also at the same time are aligned with guidelines and recommendations from trusted sources to ensure that these are healthy and sustainable dietary choices. Finally, we have the WiseFood platform. This is the layer that connects everything. So essentially, the applications that we're developing are not isolated. They're not three independent applications, but rather they are part of the same system. The platform provides the core components and ensures a common layer for user registration, creating user profile, and so on. And it provides APIs through which the applications can interact. This is shown here in some more detail, again, to make the point that this is a single coherent system, but designed with a modular architecture. So we have the platform that holds the user profiles, the data catalog, and the AI models and agents. And on top of that, the three applications are developed and they interact and they exchange information to provide end-to-end services to the user. We are using various technologies, but I would like to highlight here the knowledge graphs and the large language models that play a very central role, on top of which we have LLM-based agents and the conversational recommender. And a very important aspect that cuts across all the application is AI robustness to ensure that the use of AI is trustworthy. So with this, I will conclude the overview of the project. And in the next presentations, as I said, you will find more details about two of these applications that we are developing. So thank you very much, and feel free to reach out if you have any questions.
Thank you, Dimitris. Next, we have Siegfried Dewitte, who will present the DietWise project.
Can you see my presentation now?
Yes.
Okay. Good afternoon, everyone. Thanks for joining this webinar. I also want to thank our sister project for organizing this webinar, who were so kind to invite us as well. As you will see, DietWise is a sister project of WiseFood. There are a lot of similarities, and that's not surprising because we use the same call to make our proposal. So I'll be briefly introducing the DietWise project, but this webinar, as my colleague just said, focuses on the digital applications. And so later on in this presentation, people from our consortium will zoom in on these digital applications that we are developing. So just a few facts about DietWise. So it's very similar. We started 2 months earlier than WiseFood. We have 10 partners. Our project situates in the same topic. And so the 3 countries are Belgium, Lithuania, and Greece. 2 of them are overlapping, I just noticed. So in the 3 countries, we each time have an academic partner. We have a few behavioral scientist experts in our consortium. We have, of course, an IT specialist, and we have partners who interact with the general public in terms of health advice and so on for healthy living bureaus in Lithuania, Belgium, and Greece. And we also have a consumer protection organization, SAFE, that is also situated in Belgium. Okay, so the motivation is largely overlapping with what Dimitris just explained to you. It can be summarized probably in this figure. So we want to understand and stimulate the home cooker, who is here in the left corner, to use the information that is available in these triangles, the nutritional triangles or other sources. I just took one here as an example. What we know that people are not very, or let's say the majority of people are not very used or willing or motivated to use that information immediately or directly in their diet and their daily practice. So DietWise is actually about finding ways to facilitate that. And we have actually 2 main paths. And so the first path that we envisaged, and that's something that is that is different from how WiseFood approached it, is through the route of influencers. So we know that home cookers consult or follow influencers who give advice on cooking and so on. Some of these are not particularly experts in health, and so we want to reach them, and we are working on finding ways to approach them and to make them join our project, and by learning or teaching them how to incorporate these insights from the nutritional guidelines. And so the tool, the ICT tool that we are using for that, or the platform or the interface, is the Responsible Cooking Alliance. And Nikos and Efeli will later tell you a little bit more about that. Another thing that a home cooker does while cooking, so the focus is for us mostly on home cooking, is consult recipes on the internet. And so we try to use that channel, that natural channel, to impute the knowledge from these nutritional guidelines on the spot when people use it. So by proposing, correcting consulted recipes, I think this is very similar to what Dimitris just introduced. The recipe wrangler is very related. So what we try to do there is to recommend alternatives for some specific aspects of the recipe that are less healthy or can be replaced by something more healthy and sustainable. And our app or our ICT solution here is called My Recipe Watch. So these are the 2 main threads of our project. And so we are actually halfway. So we just passed the halfway milestone, the 1st of May. And so what have we been doing so far? We have been building AI tools. I'm not going to tell you more about it. That's something that our colleagues will tell you a bit about in a minute. We have been focusing on consumer needs so far, like what does a home cook need? What kind of information do people use? We also have been talking to influencers. We have been building an influencer training module. So how can we gently include these influencers? Are of course people with their own logic and their own incentives, so we have to be careful to get them on board. We included nutritional knowledge, so we have some nutritionists on board as well. I forgot to tell you that in the introduction. And then we also mix that with behavioral insights. So how can we boost the acceptance of our recommendations, for instance. And so the steps ahead are mostly pilot testing. So it's fine-tuning our ICT tools, of course, but also testing them. So our responsible cooking alliance uptake, we will be testing in 2 of our pilots in Greece and in Lithuania, and how to do that, how to motivate influencers to join. We will test My Recipe Watch in families in low SES schools in Greece. Also, My Recipe Watch in combined with cooking classes in elderly people in Lithuania. We also collaborate with a retailer in Belgium who provides meal boxes, and we will. They're also considering or developing an ingredient swap. So it's very similar to the My Recipe Watch. So we will also work together to test how that works. And finally, we will also launch a pilot testing of the My Recipe Watch in a randomized control trial fashion in Belgium, also with a special attention to vulnerable groups. And that is what I had for you as a very brief introduction to DietWise. I'm also very happy to answer your questions later in this session, or of course via email if you're interested. Thanks for your attention.
Thank you, Siegfried. Now Vasiliki will showcase FoodScholar and explain how it provides reliable AI-powered tools to healthier choices.
Thank you. Okay, let me switch here. Okay. Good. Thank you. Hi, everyone. My name is Vasiliki Pitsilou. I work at the Athena Research Center as a research associate, and I will first present FoodScholar to see the mechanism a bit, and then I will show you a demo of how you can use FoodScholar in real time. Okay, so let's start with what FoodScholar is. So FoodScholar is a tool that means to help users get informed on the topic of nutrition using information that comes from official and reliable sources, such as scientific articles or their abstracts, national dietary guides from various countries, and textbooks that are being taught in universities and are publicly available online. These are the data sources that we use to build FoodScholar, and we believe that they make up a good basis for nutrition knowledge. So FoodScholar essentially makes use of this information in 3 major parts. The first part is summarization. So you have a lot of information across multiple documents, and summarization is a component which creates a summary of the most important information across multiple documents for a specific subject. Then we have question answering, which is a central part of FoodScholar. In question answering, the user has a question about nutrition. The user asks FoodScholar, and FoodScholar replies based on the sources that we have, such as textbooks and articles. And the final part is browsing and navigation, where the corpus that we have collected out of articles, dietary guides, and textbooks. You can go in this corpus, browse, and find the articles or the documents that you want for a specific subject of your interest, maybe. Okay, all these features are available on the WiseFood platform, and I will show them to you real quick in a demo in a while. So we have the browsing and navigation, question answering, and summarization. Here it's the main page of browsing and navigation. You type a subject that you want, and you get the results. Here you have the summarization. I think it's better to show it to you in the demo. And finally, the question answering part, where you type a question and you have a response. Really quickly, like some technologies that are used in FoodScholar, we use some state-of-the-art techniques. We construct the knowledge graph out of the corpus that we have in order to order the information and connect information among the documents in our corpus. We use LLM prompting and generation. I told you that we have a question answering component, so we use a large language model under the hood there. And of course, we evaluate our system so that we can finally have a reliable and robust version of FoodScholar. Okay, now let me switch to the demo so that I can show you FoodScholar. So, okay, this is the platform of WiseFood. It includes all the WiseFood components, and we will click on FoodScholar. So here on FoodScholar, you can see that we have two major parts. The first is the question answering machine I mentioned, and the second is the library. The library is essentially the browsing and navigation module. Here you have three types of documents, as you can see. You have the articles, the dietary guides, and the textbooks. The articles are here. You can see articles. You can also filter by subject. Here you have the map of the dietary guides. Right now we have included guides for 3 countries. However, the rest will follow, the rest countries of the EU. And finally, here we have our textbooks. Here in the articles, let's choose a random one. This is a random article and the abstract. You have some metadata like the year, the venue, the authors. You have some links. All the articles and the abstracts are taken from the Semantic Scholar platform. And you also have some metadata like citations and some other things. Okay, very well. The second thing that we can see is, let's see a dietary guide. We have Hungary here, for example. Let's open the Hungary dietary guides. We can choose one guide like this one. And here you can see the guide on the left-hand side, the full PDF of the guide. And on the right-hand side, you have some extracted rules that are found in the guide. For example, eat cereal several times a day, eat vegetables and fruits daily, so that you can have all the rules of the dietary guide collected and not search for them on the guide. Okay, and let's also finally see the textbook section. Here we have just 2 textbooks so far. You can download it because the file is really big. Okay, now, if I now think about searching, browsing and navigation, you can also type a specific subject that you are interested in. For example, let's try vegetables. So this is my query, the topic that I want. I want vegetables. I have here a set of articles returned. Everything talks about vegetables. I can sort if I want based on relevance, most recent, title, etc. And I also have here the summarization. Remember, I told you that one of the 3 major parts of FoodScholar is summarization. So here in this LLM-generated summary, information from the top documents returned are combined into a single summary, which talks about the most important things discussed in the top retrieved documents, some key findings, some related topics to explore. And you can also filter your results if you want. For example, you may want top citation entries or the most recent entries or something else. Okay, great. So now let's go to the other part of FoodScholar, the question answering machine, which is a very important part of FoodScholar. So here you can just type a question that you want, that you're interested about, having to do with nutrition. And you also have some, here are some suggested questions you can ask, but let's ask one of our own. For example, maybe we can ask, what are the benefits of low carbohydrate diet? Okay, we are waiting for a response. Here we have our response. As you can see, the information stated are based on some sources. These sources come from the corpus that we have collected in FoodScholar, the corpus I have showed you with articles, guides, and textbooks that have been consulted by the LLM to construct the answer. So this way you can trace the response and cross-check that indeed it is correct. So we have our answer here. We have a confidence field. Right now, the LLM is pretty confident that it has responded correctly, the large language model, I mean. But the confidence may also be low or medium. You can give some feedback if this was helpful or not. You also have some follow-up suggestions, some additional questions you can ask as follow-ups. And also, you have the advanced query mode. So here you can have some control over the FoodScholar Q&A system. For example, you can choose the large language model that will be used to reply. You may want a specific one, so you can choose one of those. You can also select how many articles, how many documents will be consulted from the corpus to construct the response. You may want a fast response, so you don't care, you just select 3 documents. But you may also want a more comprehensive answer, so you may want information from a lot of articles. So you can choose many documents to be consulted out of the corpus. And finally, you have the response mode. This depends on who is using the FoodScholar question answering system. If it's a nutritionist, maybe you want the expert mode so that you have so that you can get a more scientific response. But if you're someone who is not related to nutrition as a scientist, then you can select the beginner mode. And finally, this is so if you select model only, then the model responding will not use the sources that we have ingested in FoodScholar. It will not use textbook articles or anything. It will just answer based on its own knowledge. For example, if I ask this question, the follow-up using the model only option, then you can say I have no citations, I have no sources, because the LLM, the model has replied based on its own knowledge, and it does not use the information that we have, the documents that we have ingested here, so you cannot trace where the information came from. And the other 2 options, they make use of the documents that we have inserted on FoodScholar. The only difference is that LinearRag uses also the knowledge graph that we construct out of the documents, whereas the left option doesn't, but this is a technical detail. And as a last extra thing, we also extract some tips from the articles, which are printed here in the central page of the WiseFood platform, so the user can learn about some useful tips from the articles. Okay, this is all, I think. Thank you a lot for hearing me.
Thank you, Vasiliki. Next, Elizaveta will present FoodChat.
Okay, can you see my screen? Is it fine?
Maybe just a few seconds. It's loading. Now it's fine.
Okay, so thank you for having me here today. My name is Elizaveta Kuzmenko. I'm a PhD student at Université Libre de Bruxelles, and I work on developing FoodChat, which is an AI-based meal planner. So today in my presentation, I want to focus on what current features and functionalities we have, how we incorporate responsible AI practices into building our application, and what are our future plans. So talking about the functionalities, the 3 main functionalities that we have is first the query preprocessing. So when the user submits the query, we try to identify the intent of the query. Then we behave according to the intent that we detected. Then we compile the meal plan using the recipes from our recipe database. This is essentially a recipe wrangler, the third application that we didn't showcase here today. Then we have a meal plan that we present to the user, and we explain why this meal plan was chosen for him, how it adheres to his preferences, why it's good, why we didn't suggest anything else, etc. So overall, in the end, user has a personalized and transparent result that is aligned with his preferences and also with the dietary advice. And also, I think we need to have a little demo, like a really, really brief one, to just see how it looks like in action. So you already saw our platform with a free application. So I'm going to work with FoodChat now. I think it's really intuitive. It doesn't have that many features as a FoodScholar before, so you can just master it yourself in several minutes. So here you have a chat interface. This is just like a simple chatbot that you can interact with. You have some predefined options that you can ask, but it can also be a free form, so you can ask whatever you want. But let me stick with a predefined option. Just ask for a simple daily meal plan for today. So the chatbot asks for some additional information, like, for example, what's your preferred maximum cooking time? I can answer something that I like. Then it says whether I want the recipes to be simple or hard to cook. I say something like intermediary. Then it has like, what's my goal? And I say, I don't have any goal. Just give me the food already. Then it works for a little while and presents for you the meal plan. So I'm going to talk in detail how it works a little bit later. And we have different plates for the daily meal plan and for the weekly meal plan. Also, we have different settings for making the plan explainable and transferable for both daily and weekly meal plans. So here is the result that we get. So we have 3 meals, breakfast, lunch, and dinner. We have the recipes that are suggested. We have some nutritional information about them. And we have this little paragraph that explains why this meal plan was suggested and how it adheres to the user's preferences that he expressed. And also why this plan is good for him. So why didn't we suggest anything else? You can leave your feedback. So you see here is the feedback. You can say if you like the plan or you didn't like it. Then you can actually go on. You can switch intents on the go. So you can ask here just a simple question like how much water should I drink per day? Or you can say now give me a weekly meal plan and the system will adapt and give you the result. But for the sake of time, I will leave it for you to experiment for yourself. So now let's talk about how it actually works in more detail. Is it full screen? I think so.
Yes.
Okay. So as I said, we have several steps. And the first step is query preprocessing. So when the user comes to FoodChat, we have the user profile and the user query. User profile contains personal info, also hard constraints, which are really important for the next steps. Hard constraints for now are diet and allergy. Also, the user profile contains preferences, which are basically liked or disliked ingredients. Then the user query that is submitted to the FoodChat is checked for intent. For now, we have 3 types of intent, which is chatting, getting daily meal plan, or getting weekly meal plan. And in future, we plan to add more intents like modifying, giving advice, etc. So first, it's very important if hard constraints are violated in the query, then we converse with the user again. We ask if it was really his intent that he has some allergens that are harmful for him, if he wants to replace them. And if the preferences differ in the user query compared to user profile, then just the query takes precedence. We don't really care what's in the user profile anymore. Also, if you've seen before, we ask clarifying questions for some additional information. For now, it's the diet goal, like if you want to maintain or lose weight, the cooking difficulty, and the desired time of cooking. After doing all this query preprocessing, we end up with a new reformulated and or expanded query, which we use in the next steps. So the next step will be the actual daily meal compilation, how it works. Well, we identified our hot constraints, we identified the user preferences. So we filter the recipes in our database according to the hot constraints, and all the filtered recipes are organized by meal type. As you have seen, there are 3 meal types, which are breakfast, lunch, and dinner. Then having all our categorized recipes, we just compile all possible daily meal plan combinations, and then all possible daily meal plans are scored with 3 metrics. So the metrics are the following. The first metric is the alignment of the meal plan with the user preferences. So how well what we propose in this meal plan adheres to what the user initially asked for. The second metric is the food variety, because we want our meal plan to be as diverse as possible, because it's good for our health and it's a simple metric to calculate. And then the third metric is the adherence to nutritional guidelines. So we need to take into account not only what user wants, but also what is good for his health according to the dietary experts. So when we have all these metrics, below you can see the total metrics. So it consists of 3 parts, as I said. You can assign different weights for them. So depending on what the user or B, consider the most important, be it adherence to nutritional guidelines, adherence to preferences, or the food diversity score. So we select the best plan and we present it to the user. And all the rest is stored, maybe for variability, if the user wants something to change, and also for explainability purposes. So now talking about weekly meal plans, they are both similar and different from compiling daily meal plans. The steps of recipe filtering and meal scoring remain more or less the same. So it's the same logic. You filter the recipes that satisfy hard constraints and you score the meal plans according to user preferences, nutritional guidelines, and food variety. But inside logic of compiling a weekly meal plan is a little bit different. So we have some constraints, which are basically how many meat dishes we should consume per week, how many fruits we should consume per week, what should be the calories limit per week. So we need to satisfy all these criteria, and also we want to maximize the rewards, and the rewards can be having food variety score as high as possible and also have a good alignment with preferences, good alignment with nutritional guidelines. So we solve this as a constraint satisfaction problem. So over the space of all possible meal plans, we search for the optimal plan that satisfies all the criteria above. And similar to the daily plan, suboptimal plans can also be stored and used later for explainability or variability. So we have all this, but it's important not only to present result to the user, but also make sure that it's trustworthy and fair. So we put a lot of stress in our project on the trustworthy AI framework. For WiseFood, it consists of 4 criteria. The first criteria is alignment. So basically, it's how well the information we provide to the user aligns with the nutritional guidelines, and also that the experts participate in the pipeline, correct the system where necessary, and overall, there is a human oversight over what happens. The second criteria is bias and fairness, so that all the recipe collection that we have is not discriminative in any sense, so that we don't, exclude some cuisine or some societal group from our consideration, and also that we don't discriminate against users based on their race, age, or gender, or any other criteria. The third point is transparency, trust, so that the users understand what data they give to the system, how it's used in the system, why do they get the results that they get, and how it can be explained. And the fourth point is robustness and safety, so that our system does not give out something that may harm the users, and also that is resilient against attempt to break it and make it produce something harmful. I'm not going to speak about everything about all this in detail. I will just focus on 2 criteria. First is alignment, and second is robustness and safety, and describe how we achieve it for FoodChat in particular and WiseFood in general. So let's start with alignment. Alignment works similar for all WiseFood applications, and it works on 2 levels. The first level is the model level alignment, and the second is output level alignment. So for the model level alignment, we make sure that all the models, language models, and the databases we use are aligned with nutritional guidelines through prompt conditioning and fine-tuning. So basically, we tell to the model in prompts which results we expect from her, which are the criteria that should be satisfied, and which information should be avoided. Also, there is possibility to fine-tune the models with nutritional guidelines directly, so that they produce the results that adhere to the guidelines by design. And second, if we already have the output from the model, we still need to make sure if it's really aligned with what we want. So we check the output level as well. So we distill the rules from the guidelines. You saw it actually in the FoodScholar demo, that there is a nutritional guides and that there are the rules that are extracted from it. So we make sure that everything that we show to the user is aligned with these rules, and the user gets a cleaned and aligned result in the end. Now talking about robustness and safety, well, first we need to define what is safety in our domain. And there are 3 different directions to it. First, there is nutritional safety, so that every meal plan or the recipe suggestion or any information is calorie sufficient and nutritionally balanced, so that we don't give the users the meal plans of 300 calories or a daily meal plan of 5,000 calories, so that the user will be safe and sound. Second, there is physical safety. Like, the beginning of AI era, there was this famous example when ChatGPT suggested to add glue to pizza. So this is what we want to avoid at all cost. And also we need to make sure that all the allergens are removed, because if the user takes the dish that contains the allergens without knowing it, it will be a really, really big trouble. And then there is informational safety, so that we don't give some misinformation. So we don't make statements that are doubtful. We don't make statements that don't align with dietary advice. So this can be achieved similarly to alignment on two levels. First is the model level, and second again is the output level. On the model level, it's achieved also through controlled language generation. So we specifically tell to the models what they should give us and what they should avoid, and they try to act accordingly in most of the cases. And then we need to double check if they really behave as we wanted them to. So we have guardrails, so we just do input and output filtering and post-processing, so that nothing harmful like suggesting to eat, I don't know, glue or a drink, quicksilver is slipped through the output of the model. So in the result, we have reliable and safe AI meal planning for WiseFood. So what are our next plans? Well, of course, we want to make better FoodChat, and there are 3 criteria by which we want to achieve that. First is enhanced conversation. We can enhance conversation in several ways. First, like there is a really common intent of the user to build on something. Like you have these ingredients in your fridge and you want to compile a meal plan that uses them. Second, we want to critically refine results. For example, you suggested a meal plans and the user says, okay, but I want to replace salmon with chicken and I want to make it more spicy or less spicy. And the third option is to substitute ingredients. So for example, you don't have something and you want to remove it from the meal plan, but the alternative should be as close to the initial suggestion as possible. The second dimension of making FoodChat better would be transferring from user to household. We already have users grouped by households, but we don't really use the constraints and preferences from the whole household in general, so it will be the next step. So for example, we have a family and they have different diets, they have different nutritional preferences, and we need to satisfy all of them if possible. And also, we already put a lot of stress on responsible AI, but we still need more. So we need to make our apps even more explainable, more safe, and more trustworthy. So this is it for me. If you have any questions, I'll be happy to answer them later. And if you have any comments, if you have any feedback after you try out FoodChat or any other application, do not hesitate to reach us. So here is my email. Thank you.
Thank you, Lisa. I'm pleased to invite Nikos and Efeli to share their insights on building DietWise digital tools.
So, hello. Let me share my screen. Is it visible to everybody?
Yes.
Okay, thank you. So, Siegfried told you that the general concept of DietWise. It's very close to what we have discussing about WiseFood so far. It's very interesting too. My motivation for this presentation was to share. Well, you can't share all the knowledge of the technical tools of the project, but maybe share and in a way disseminate what did we learn and what did we build, in case anybody, of course, wants to follow this work or even build on top of this work or complement it. And yeah, for me, this was this was a question. Seeing the overlap between projects, it's a good thing that we communicate even at some point in time, even after we actually finished the main development, to at least exchange ideas and see how can these things move forward. Yeah, so Siegfried explained what did we build, and let me focus a bit on the scope of these digital tools that we created. And there are 3 pillars to make the development pragmatic. So first of all, we propose alternative ingredients. The idea of both ICT tools, My Recipe Watch and the Responsible Cooking Alliance, is well, to improve recipes found online. Now, maybe you can improve a recipe in many ways. We focused on one, ingredient substitution and proposing alternatives. Now, the second thing is about personalization. And again, you have to take into account to whom are you proposing this alternatives. Just like you said, if we propose something that maybe the user is allergic to, we are in trouble. However, we chose not to gather too much personal information in this project. So we are only taking into account biological gender and age of the user. And yeah, and number 3, these two are used. These two bits of personal information are used to rank the suggestions we give according to the global burden of disease study. And I will give some more details later on if people probably don't know about it. So again, like you said, what is the overview of the technical solution? We have two kinds of users. We are interested in two kinds of users: the influencers and the citizens. It's what Siegfried described in the beginning of the webinar. So mostly we have created two tools with very similar functionality. One that addresses the influencers, one the citizens, the mere mortals. And the Responsible Cooking Alliance is the tool for the influencers. The My Recipe Watch is the tool for the citizens. Both of them rely on a common infrastructure, if we want to talk technically, but also in terms of business, these two things do almost the same thing. Maybe, yes, the Responsible Cooking Alliance, the application for influencers, does not take into account personal information because it is supposed to be a tool to help the influencers build their content, create a recipe and assess it in terms of healthiness and sustainability. So yeah, no personal information, but other than that, it's mostly the same. And on the other side of the screen, you can see a screenshot of how the mobile application looks. Oh yeah, I forgot to mention, the Responsible Cooking Alliance is a browser plugin, a browser extension, so that it can read online content even if it is not published yet. So me as an influencer, I want to assess a preview, an unpublished preview of my recipes, and see how it goes and if there is room for improvement. So this browser extension is a helpful tool for the influencers. On the other hand, for citizens, we provide a mobile application, which is what you see here on your screen. And what it does, you give it the web address of a page containing a recipe. It extracts the ingredients of the recipe and displays them on the screen. Under the hoods, it also extracts the preparation steps of the recipe because they are needed later. I will show you. And then it thinks, it applies an algorithm, as a matter of fact. We will come to it in a later slide, and provides the suggestions you see below. And the user may accept or reject or be neutral on one advice. if the users accepted an advice, you see this this strike through ingredient in the top ingredient list, replaced with what the user has chosen. And what is not visible, as a matter of fact, I realize now what is not visible in this screenshot is that we also incorporate information about the cost category of the replacement and the seasonality. These were a bit recent additions, so I obviously have added an older screenshot. Cost, we provide cost per country, and it's not a real cost. It's not 22 euros. It's just a very coarse ranking: cheap, average, and expensive. And for seasonality, we take into account the current date. We have information for the substitutions, and we inform the user if one of the alternatives we suggest is out of season or not. So, yeah, like I said, and although we are incorporating AI in the algorithm, in the end, the suggestions come from a deterministic algorithm. Why is that? The thing is that AIs are a bit of a black box. We couldn't follow. We would have to go through an extensive training or fine-tuning period in order to make the AI understand all those rules. And then, if something goes wrong, there's not very specific things you can do. Maybe retrain, maybe or actually refine tune. We're not talking about training here. We chose to, well, since our dietitian experts gave us rules about those substitutions, we chose to implement it by a deterministic algorithm. The second bullet is what I was talking about. This algorithm gives us access to the intermediate results, so we can we can intervene if we see that some specific part of the algorithm is not performing well, and improve just specific steps in the process. Or arbitrary suggestions. As a matter of fact, this algorithm offers suggestions from a curated white list of ingredients. So there is no way we will suggest glue as a substitution. It's definitely curated by our experts. Yep. And the system predictability and ease of reasoning about it were facts taken into consideration when we made the decision to go for a deterministic algorithm. So what is the role of AI here? We start from a recipe page written in a natural language, and AI is giving us nowadays this opportunity to extract structured information from an unstructured or essentially unstructured text. And there is a component in the system that can read a recipe page, filter out all the unrelated stuff, the menus, advertisements, comments, etc. Keep the recipe ingredients and steps of preparation, and feed them to the next steps. As a matter of fact, just to assist the AI tools here, we are also using, if we find it, the JSON LD content of the page. And I'm going to talk about JSON LD for just a minute, because maybe people haven't heard of it. And JSON LD is a data format. It's not in plain sight. It's if a page contains JSON LD data, they're not visible on the page, but they're visible on the code, on the HTML of the page. And I was surprised to see when we started the development of these tools that most recipe sites actually adhere to this JSON LD concept, and they include the recipe that they display on the page into they include it in this structured data type, the JSON LD. So what we do, if we do find JSON LD in the page, we are using it instead of having the AI determine and extract content, the recipe, and maybe, hopefully, we have seen pages where the JSON LD was broken, as a matter of fact, but in the majority of the pages we tested, vast majority actually, JSON LD was correct. Now, what else? Next role of the AI is a kind of fuzzy matching, a classification of the ingredients found in the recipe to those in our database. I will show you what is the form of the rules that were written by the experts. But one key component of those rules are the trigger ingredients. Trigger ingredients are, so to speak, some template ingredients that if you find them in your recipe, they trigger this rule and the corresponding substitutions. Ingredient composition, breaking down a recipe into the rules that we feed to the global burden of disease data to get the ranking. And also the AI has a role in determining the best fitting recommendation among the various alternatives. So what is the algorithm? And this is a simplified version of it. First of all, extract the recipe, which means what? As I said, ingredients and preparation instructions. We take into account the JSON LD content. The second step, we classify the recipe ingredients. So we take an ingredient from the recipe and we map it, actually the AI maps it to the generic trigger ingredient plus a role. It will become clearer in one of the next slides what is the role. And then, as a matter of fact, the trigger ingredient and role are the coordinates we are using to search for the most appropriate rule. And this is the third step of the algorithm. And finally, each rule contains alternatives, one or many, and we make a suggestion taking into account the user personal information and the user preferences. If users tend to a specific user tends to consistently reject a substitution, then we will try to suggest it with a lower priority or even not suggest it at all. Yeah, and this is the raw format of the rules. What we have, the first column is we call it the recommendation, and this is the thing that is based on the global burden of disease study. So, so what do we see here? We see that the global burden of disease suggests a diet with decreased red meat. Okay, that's one. That's a recommendation. What is red meat? It's beef. It's pork. You will see it's lamb. Later on, it's not visible here. So this is the trigger ingredient. We can find beef in many forms, and this is why you have beef, for example, in three rows here. And the third column is the role or technique I mentioned earlier, which is exactly what the example says here. We're using beef how minced in sauce. We're using beef how in a stew, or maybe in a steak centerpiece. And for each of these roles, there are different substitutions, because it's quite different. The candidate substitutions are quite different if the beef is a steak centerpiece, or it's cubes or minced in sauce. And then we have the alternatives and the restrictions. We try to make the restrictions visible to the user, but not enforce them. So, for example, for example, here we could propose hummus plus walnut instead of luncheon meat. This is not for nut allergy. We provide this information to the user, but the users have to judge for themselves if this is an appropriate substitution for them or not. Yep, and here I'm explaining. I'm showing what I explained earlier, as a matter of fact, which is what is the substitution logic. So, if we find beef in the recipe, we propose to substitute it with brown lentils cooked, if the role of ingredient is minced in sauce. And the restriction is not for burgers without binder. And this is something that's just displayed to the user. Yep, that's it. And let me jump into some more technical details here. Again, we have the components of this application. The users, the citizens, and the influencers, they have access to some recipe sites. The influencers are using the Responsible Cooking Alliance browser extension, which has direct access to their browsers and the content they are seeing. On the other hand, the mobile application does not have access to the user's browser. For this is enforced by the mobile platforms for security reasons. So we ask the user to enter the address of the page, and then this rendering service, a backend component, reads and renders the address that the user gave to read the recipe. After obtaining a recipe, actually after obtaining the content of the page that contains a recipe, process is common for both of these. And we're using Olama for running and exposing internally the LLMs, Postgres, and Java plus Quarkus for the application itself. Yep. Code is available on GitHub. You can find each of the tools we developed in these repositories. And let me talk a bit about the results we're getting, although we haven't commenced the full test phase. It is about to begin in the next weeks, actually. So we have encouraging results. We have an extensible application, and as I said, not thoroughly tested yet. It usually gives reasonable suggestions. The rules may need a bit of fine-tuning. This is easy to do. It's let me go back a bit, because this thing here, this is obviously an Excel file, but this is reflected in the system's database. So if we actually want to adjust these rules, it's only a change in the database. It's no retraining or any LLM operations used. If we add a rule, it's there. It's very quick to extend the set of rules. Yeah. One more thing we found useful to do was to add some columns. Again, I'm going back to the data, to add some columns that give some more information to the LLM about the trigger ingredient and the role, and actually the other columns too, so that the AI has more context to better match the trigger ingredient with the ingredients of the recipe, and the role or technique with the instructions of the recipe. Yep, and we need testing to see what other faults will the system produce, so that we can correct them. Yep, and in the end, I would characterize this application as fairly extensible platform for dietary advice. And there's always room for improvement. And our ideas on this, these are our ideas. How could somebody extend this system? So, first of all, is read the recipe from any media. There could be an added component that extracts text from a video or a sound file, and then this same algorithm could extract the recipe from this text and make suggestions. It's not very beautiful, so it could benefit from some beautification and improving the user experience. We are waiting feedback from the users, actually. Household level cases. This application, since it takes into account the age and biological sex of a single user. But what about me? I have a family. I have to cook for me for 3 people, maybe somebody else for more. What then? And maybe today I have invited my parents, a totally different age group. Maybe there could be an improvement for that. And then some other usability things. Currently, we do not remember choices per recipe. This is an easy thing to add to the application. And then the last before the end bullet is actually we have a few recipes that this is our test set. I would very much love to see this test set expanded and have the expected results well documented, so that we can assess the performance of any changes we make to the algorithm of the system. And finally, it's a bit slow right now. There are ways to improve speed. We are investigating. maybe I should open a parenthesis here and go back to the technical implementation. It's something I forgot to mention. The fact that we are using the AI for very specific questions, for very specific tasks, gives us the opportunity to use a bit smaller models, which should be cheaper to use and operate. And this may be a way to improve speed. Yeah. Move on. And then again, we can do logic enhancements in this application. We could do some fine-tuning or domain adaptation for the LLMs and introduce some more sophisticated AI operations in this workflow. Somehow this would be maybe a large deviation from what we implemented so far. It's very easy to tweak LLM parameters like this, the size of the model, the temperature, and technical stuff like that. Personalization, maybe dietary habits, allergies. This is another way to go. If and in this case, we need to expand the rules. And of course, the algorithm itself, it could be improved. I guess we need to test it first, see how it goes, and then see if there is room for improvement for the algorithm. And I believe, content enhancements. For the time being, we have only a few dozens of rules. These are easily extensible. If the dietary expert group decides to add rules, we can very easily incorporate them in the application. Maybe advice for preparation instructions, and offer some more value to the influencers, because right now the functionality is more or less the same in those two tools. That's all from me. Thank you.
Thank you to all of our speakers for your insightful presentation. Let's move to the Q&A session now. Please feel free to type in the chat all the questions you have, and then we can answer them. We have a first question from Anastasia. I'm very interested in the collaboration with healthcare professionals. Which dietetic experts should we reach out to for the validation protocols of these tools?
I don't see anyone answering. I'm not sure what exactly, Anastasia, what exactly would you like to learn? In our consortium, we had the dietitian experts, and they formulated those rules. Details, I can give you the organizations of our experts. Don't remember them, but I can find them in the presentation. But is this what you're asking? I'm not sure.
Yes, she's asking that.
Okay. And I hope I'm not missing anybody. We had the International Hellenic University Prolipsis Institute from Greece. We have KU Leuven from Belgium, I believe, and SAFE from Italy. And Siegfried, am I missing anybody?
Yes, the Public Health Bureau of Lithuania is also part of these healthcare professionals that we included. But of course, it's an ongoing process, I guess, right? So if you have other dietetic experts, you can also always check. It's a learning system, I guess, Nikos, right?
Of course, yes.
Yeah.
Dimitris, do you want to add something?
Yes, also similarly from our side, RCSI is the leading partner for the living labs. As we mentioned in the introduction, this is a part that is a very important part apparently, but was not covered in detail in this webinar. So as part of the living lab activities, we have such kind of protocols for establishing the living labs, carrying out the co-design and the testing activities. There is also a publication underway. So I have included here in the chat the name of the person. It's Claire Timon from RCSI. She can definitely provide more information about these details.
Thank you for your answers. Do we have more questions? If anyone wants to add some questions, they can also type it. If not, thank you for to all of you for your questions and presentations and also answering. To close, I would like to once again invite people to follow us on social media and also to visit both websites for more information. We hope today's session inspires you to think about how AI can be used responsibly to empower citizens and support sustainable food choices. Stay tuned for more, and thank you, everyone.
Thank you.
Thank you very much, Sandra, and
Thank you
everyone.
all. Bye.
Thank you.
Bye.
Bye-bye.
Bye-bye.